Hello everyone, welcome back to our channel. In this series of video, we are going to discuss about the computer organization and ARM microcontroller 21EC52 model question paper dealing with module 1. Come, let's go into the video. So module 1, you have these three questions. Let us not see about the split up marks given here. We'll just focus on the important question that is given in the model question paper. So these are the three. So when you see here with a neat diagram, describe the functional units of computer. Yes. So here when you see, you can draw the functional unit of the computer completely with the blocks, and each blocks can be explained. So the functional block may contain 4 marks and other 6 marks will be covered in your explanation of each blocks. Explain Little Indian and Big Indian byte address assignment with neat diagram. Show how this number is stored using this method. So you have to explain what is Little Indian, what is Big Indian, and then with this number you have to store it in form of Little and Big Indian. And the third one is with a neat diagram, describe the operation concepts in a computer, highlighting the role of PC, MRA, MDR and IR. So you have to first draw the diagram for that, which will carry 4 marks, and explain all these roles which carries 6 marks. So moving on to the solution, here you can see the functional unit of the computer. So with memory, input output, this is the input output interface, and there is a processor where there is a control unit and arithmetic logical unit, and memory plays the main role. So this is the functional unit of your computer, and each of this block, what is input, what is output, what is memory, what is arithmetic and logic unit, what is control unit, what is full processor means, what processor we are using. Explain all those to attain complete 10 marks. Moving on to the second question, we saw it as Little Indian and Big Indian. So here this is the diagram. You can see like Little Indian is nothing but little means lower order byte. So little, when you see, it is lower order byte. So the starting address, if it is A, then the lower byte address will be stored in A, and A plus 1, the next higher order, A plus 2, the other order. So from lower order to higher order, the bytes will be stored in the address. Address will be ranging from the lower order to the higher order. And Big Indian is nothing but big. So it is high order byte. So high order byte will be stored in the starting address. So starting address is A. So in the starting address, high order. So like you can remember that Little Indian is ascending order, Big Indian is descending order. So with the starting address, it starts with the high order byte address and follows, keep on filling it. Like this, you have a one particular problem, that is number given in your question. Now you can start filling that in based on Little Indian and Big Indian. Specify which is the starting address and the ending address, and start filling your byte of address. And the third question was, this is the complete architecture. So here you can see that program counter, accumulator, general purpose, so different registers, accumulator, what is stack pointer, what is different kinds of memory, what is the main memory that has been used, how it has been mapped with CPU, all those can be explained with this diagram, this block diagram, and list out what is program counter. So program counter is nothing but it is having the memory address of what. If suppose if you are executing one particular address, then it will be pointing to the next instruction that has to be executed, that is program counter. MDR, so it is nothing but it is the communication done with the memory. MAR is nothing but it is going to keep the address of the location that we need to access, that is MAR. So you can list down few, so that 5 marks, totally 10 marks it will cover. Moving on to the next part of the question, or choice. Explain the IEEE standard used for single and double precision floating point number representation with example. So you will first determine what is IEEE and what is IEEE standard for single and double precision, and then with example you can quote how single and double precision floating point is represented. And next, perform subtraction on the following pairs of number using 5-bit signed 2's complement format. So here you can see, so in 2's complement format, here when you are doing subtraction, there are various ways. That is both with minus signs, both with plus sign, one plus and one minus sign, how to add and subtract, we would have learned, right? So with that, you are going to take here plus 12 and plus 9 is nothing but you're going to take the 2's complement. So 12 is, what is the binary value of 12? What is the binary value of 9? Then do 2's complement for that binary value of 12 and 9, and using 5-bit you have to perform the subtraction, and then you have to determine whether there is any overflow. That is, overflow is once you subtract, if only 4 bytes has to be there, then 4 bytes. If there is any fifth bit remaining, then that will be your overflow bit, that you have to indicate how you have got the bit. So you will perform all these three using that formula. And next question, discuss the following with an example. 3, 2 and 1 address instruction. So you will determine what is this, and you can quote with an example to attract the evaluators. Yes. So moving on to the scheme. So here you can see for 32-bit and 64-bit. So 32-bit you have 1 bit of sign, and exponential 8 bits, and mantissa 23 bits. So the same will be followed for 64 bits. So these are the 2 bits. This you can draw and explain. With example you can quote it. And next, problem based. For n bit, this is the formula. If it is 5 bit, this is the formula. Use this formula after you do the 2's complement of the given number. And then finally, the last question. So how one address, 3 address, 2 address and 1 address. So 3 address is nothing but it consists of a opcode, destination and 2 sources. 2 addresses, opcode, 1 source, it might be destination also or source also, and the another source. 1 address is nothing but with your opcode you will have the address of the opcode and which mode it is. It is 1 mode, 2 mode, it will be indicated. So the opcode is the one which plays the major role here. So this is the format that you can specify for 1, 2, 3 address instruction, and then instruction can be quoted for three program instruction, 3 code instruction. Then what can be done? So one opcode can be written with a destination and a source. So source 1 and source 2 you can write it as A comma B. Destination is a register R1. So the content here can be moved to the register R1, where opcode can be written as move. So moves opcode will be typed in the circuit board. Yes. So this is how you have to explain in detail. Please stay tuned for still more tips for solution. Thank you.